Hi, I'm Donna Pearson from the National Research Center for Career and Technical Education, and it's my pleasure to present to you this series of videos on Math-in-CTE. We receive requests daily from teachers and administrators around the country wanting to know how the Math-in-CTE model works in real classrooms with real teachers. And these three videos that we are presenting offer you the opportunity to see a variety of teachers teaching a variety of CTE content using the Math-in-CTE model. If you haven't already done so, you might want to take a look at the materials that are on our website at NRCCTE.org, and you might also want to view the fuller video on the Math-in-CTE model. Essentially, the 7 elements offers the teacher a framework by which to develop a lesson and to teach a lesson. And this framework, in its 7 elements, offers an opportunity for a transfer of learning from the math that's embedded naturally in CTE to the explicit mathematics. And in this way, students are able to understand mathematics and learn it contextually. In each of these lessons, the instructors have used a 7-element lesson plan to guide their instruction. However, I'm going to point out and highlight the elements that they have used particularly effectively for these demonstrations. I hope you enjoy the videos.
Scratch is a program developed at MIT, at the MIT Media Lab, by a group called the Lifelong Kindergarten Group. And I would say, as a software person, that it's the best educational software I've used. It's a multimedia-rich programming environment that allows students to create dynamic stories, to make presentations, to write programs. It actually has a lot of what we would consider 21st century literacy skills all integrated together. So it's a programming language, but it's one that has a paint program built in that you can actually mix a MIDI and mix music, and you can have characters talk to each other and move around and interact. You can write games, you could tell stories. One of the first things you have to do in the Scratch world, the metaphor is a stage, and the stage is a coordinate plane. So it has a location, 0, 0s in the center, and there's an X and Y axis. And if you're going to move what are called sprites, which are the actors in a Scratch program, around the stage, you have to really develop a deep understanding of the coordinate system, because otherwise you won't be able to do what you want to do. So that's just the beginning. There's also basic computer science things like conditional branching and looping and message passing. So all of that stuff is built in as well. But we're going to start out with a fundamental understanding of something that a lot of students have difficulty with, plotting points.
One thing that we would like you to see in this video is the fact that the Math-in-CTE framework can be used in a variety of ways, in a variety of instructional styles, whereby one teacher may use the elements, the 7 elements in order. Other teachers who are more student-centered will use those elements in a different order. Here we have Mr. Zawolo and Mr. Elkner from Arlington Career Center using a very student-directed approach to their instruction. This team of instructors effectively uses questioning to engage their English language learners in a lesson about the math that's embedded in their software programming. Notice how they use questioning to draw out the math understanding of their students. They allow many activities in which students are allowed to ask questions, but also to demonstrate at the board to their fellow students throughout this lesson.
Today we're going to do a Scratch project that involves using changes in the X and Y values of an object to move it in the coordinate plane. And what we're going to do is we're going to have you clean your room, because we know how hard it is to get teenagers to clean your room. So we thought this was a great opportunity to do that. And what we want you to do is to click on the procedure where it says download this Scratch program to your computer. It will ask you to open with Scratch. Do that. And when you're done, you should all be looking at this. So I'm going to ask you a couple of questions. Please raise your hand. First of all, how many sprites do we see in this program? Raise your hands, please. Mr. Treminio. 3. Now, somebody else, name one of them. Ms. Melgar. Laptop is one of them. Mr. Campos. Monkey is another one. Excellent. And finally, lamp. Excellent. So those are the 3 sprites. Now what we want you to do is take a look at the scripts that belong to each sprite, because I want to ask some questions about that. So if you click on the Scripts tab when you select a sprite, you can look at the 3 scripts for those sprites, and I want to know what is the same about them and what's different about them. So do that. You can go in on your own screen, click on each one of those sprites.
Click on each one of the sprites, observe the scripts, and identify the differences and the similarities. Hold on for now. We're going to discuss that soon. Everyone is ready, and I'm going to discuss it, okay?
Okay. What is the same about each of these scripts? So raise your hand.
Chain X and chain Y.
Okay. Is always set to
10.
And then what causes that change? That's another question I want to ask. What is the event? What happens? What do you have to do to make X and Y change by 10? And you have to read the block with the hat on it, which is an event.
So
what event causes X and Y to be changed? What does it say? So what do you think you have to do to move things by X and Y? What? Exactly. So you can try that. Watch what happens. You press the space key, and there they go.
Could you try pressing the space key and see what happens? Okay, Brian. Nice music.
Okay. So what was different about each of these scripts? Mr. Martinez.
X and Y are different.
What do you mean?
But
Where?
in the first one, when we got click on the green flag,
Yes.
all the X and Y chain.
Yes. Good. Excellent. If you click the green flag, they'll go back to their starting position. That's right.
But did you consider the difference between the X and Y for the lamp and the X and Y for the laptop? Are they the same?
No.
Why? Why are they the same?
They go to different place.
Excellent.
Excellent. Yeah,
Yeah.
in different positions, right?
So each one has a different starting position. And that's because they have a different X and Y value. And when you click the green flag, they go to that starting position. So your job is to make these things go to where, basically you have a messy room. And you want to clean your room. So the laptop should end up here on top of this desk. The lamp should end up here on top of the dresser. And the monkey should end up on the bed. And here's the rule. So don't do anything yet.
Don't do anything yet, please. Hold on.
You are only allowed to change these instructions. And you should, when you're done, one space bar should clean your room. So the goal is to be able to press the space bar one time and have each of those sprites go to where they're supposed to go. So you're cleaning your room. Do not, please do not change this instruction. Because when we click the green flag, we want to make a mess again. We want to put everything back on the floor where it started, and the space bar will clean your room. Go ahead.
Please notice how Mr. Zawolo unwraps the mathematics that's underneath the plotting. In this way, he makes the math very explicit to the students only after they have positioned the sprites. In this way, they have changed up the order of the elements, but still effectively transferred the knowledge. At the end of the lesson, notice how they offer more opportunities for students to practice in the form of homework.
Before you do that, let's have an overview of the math that is involved. Mr. Elkner, can you input a background with the coordinate plane?
So I'm going to click on the stage.
Can we look over here, please, everybody? Please look over here. So now, as you can see, each of our objects is on a plane, right? Yeah. Each one of them how do you determine the location of this laptop? What is the location of the laptop right now? How do you determine that?
Negative 100.
Negative 100?
Comma negative 100.
Negative. So how do you get that?
X and Y.
X and what? Y. Okay? So to be able to do this project, we need to know something about what? Our coordinate plane, right? We need to know about our x-axis and our y-axis. Which one of these axes is the x-axis? Where's the x-axis? Where is it?
140.
X-axis? Go that way. Okay, how do you say that? Anybody knows the word for that? It goes what? Horizontally. And the y-axis goes what? Vertically, right? Okay, so to be able to move each object in the place that we want to move it, what are some of the things we think we need to know? What math do we need to know to be able to do that? Algebra? What in algebra are we supposed to be doing? What are we going to do? Basic math? But what do we do? What operations, what particular algebra thing that we would do to take us there? Equations, right? First of all, let's look at something, okay? Where's our laptop located initially? Okay, let's go to the smartboard page on title. Smartboard. So you said it was negative 75, negative 140, right? Now, let us go back to the screen there. Now, where do we want to put the laptop? Okay, let's go over there. So what's the new location now? Negative 189 and what? 72. So we want to take it to what? Negative 189 to what? 72. Negative 75 is a value for what? Y? X. Excellent. So now, I want to move my X to a new location of my X, right? So how do I do that? Negative 75. Plus X equals negative what? So do you see? Right? So we're going to be using equation to get our work done. So go ahead and start and see if you can apply similar knowledge to all of the things you have to do and put each object in the right location. Try it. You have your notebook. You might have to use a calculator. You might ask us questions if you have them. And we also want you to design it so that you only have to press the space bar what? One time.
Great work. What we want to do now is come back together and take a look at how this problem is solved. And we're going to take volunteers to come up and show us how they did it.
I did the lamp. I just changed the X and the Y. I did the process that Mrs. Zawolo teaches us to do. I did the X first. I did minus 190 plus X equal 198. Then I did plus 190 plus 190. And then I take X equals 388. And I put in the 10. I put the 388. Then I did the same thing for the other one. I did minus 100 plus y equals 79. Then I put plus 100. Plus 100 move to the other side and I take y equals 79.
79? Okay, 1 second.
Then I did the skid bar.
No, click the green flag first.
And then I click the green flag and stuff.
And now the space bar.
The
And there it goes. Look, the lamp. The last one we have to do is the laptop.
Before you do the math, just think, yeah.
And the laptop starts out at what position?
Negative 75.
And?
Negative 140.
Okay, and we want to end it up here.
Correct?
So what's our first equation?
Negative 137.
Yeah.
Let-
Yeah.
All right, so let's do this.
What's the first equation again, Ms. Santos? Negative 75, right? Is that an equation? Negative 75. What? Plus x equals negative 189.
Well, it's not 189 in this case. It's 187, but close enough.
Okay.
So, Mr. Zawolo, do you want to write that out? Because you're better with this smartboard than I am.
So then how do we do it?
Take off positive.
Oh, shake it.
Positive 75.
I don't know what happened.
Mm-hmm.
Cancel the third one.
What? Good.
X equals
X equals
negative
negative
100.
negative 1 what?
Why 1?
And
You're adding the wrong way.
oh no 20
1 what?
22. Wait, no. One.
Negative what? 12.
No, not even.
Negative 12. Negative 12. Negative 12. Negative 12.
Is that right?
Yeah.
No, we're subtracting a negative and a negative.
That's a negative and a positive.
We made the 75 a positive.
We made 75 a
Oh,
positive.
plus 75. Oh, okay, plus. All right.
Okay.
So
good.
it's negative 112.
Right.
And I don't know what happened to our monitor here, but
Okay, you got
there
it.
we go. Okay. All right, so we're going to put in negative 112.
Okay.
All right, and then the y coordinate. Look at the y coordinate.
Use the formula, same thing, mister.
Okay.
Use the formulas.
All right, well, so what are the values? Try to remember the values.
72.
Y starts out at negative
Negative 40.
140
Okay.
and becomes positive 72.
So what do I write first?
Negative 140
Mm-hmm.
plus y.
Plus y.
72 equals 72.
Okay. Then what am I supposed to do?
We have
Change
we have
140. Cancel
200. 2, 1, what? 2.
All right, very good.
Now, if they're not sure, we're going to
So
see
let's
it.
try it.
Yeah.
2, 1, 2. So we'll click the green flag. We start off with a messy room. 1 click of the space bar. All right, Mr. Zawolo has some worksheets for homework for you to practice your math.
Okay.
And we'll see you all tomorrow.
Again, this is a great example of how an instructor can use the 7 elements to conduct a student-centered classroom. I would like to thank you for your interest in Math-in-CTE. If you have more questions, we invite you to visit our website at nrccte.org. Thank you.